5 minutes or 11 minutes late, so sorry about that. I'm Jacob, I'm the president of THI Kerala, and thank you all for coming for this session on AI. Many of you know about THI, and many of you don't. So we are here to, the tagline of THI Kerala is to create an entrepreneur in every home. If you take it a little more macro, it would be about promoting entrepreneurship. And we're trying over the years to actually work on supporting entrepreneurship across the globe, and in THI Kerala, particularly in Kerala. We're tied up with the governments now, and so we've actually tied up with KSUM, KSFE, Kinfra, and we're also talking about not just startups, but also scaling up. So can we get small and medium industries to scale up to the next big industry? And what are the things blocking? So there's a lot of dialogues happening with the government on that. In the meantime, what we're trying to do is create more such interactions now for our membership. I think this is the first one we're doing in a while. So what we try and do every month is to have one interaction like this. And also, we try and get more charter members also coming for these so that you can interact and network. One thing I found when I walked in was everyone was at their tables looking into their phones. I assumed all of you would be talking to each other, but I think you were busy on your phone. So I think platforms like this are to meet others, meet people that we don't know. So please use these occasions so that you can meet and collaborate with others who actually come to the same conference. So I would welcome Venkatesh to kindly introduce our speakers. And Pradeep, thank you once again, Pradeep and team. It's back to back the second day now. And I'm sure this crowd will understand you far better probably than what I was just telling them. For me, I'm a chocolate here, so understanding bio and AI was a little, so I was asking Jimon, just explain what happened actually. So, but I'm sure this crowd will be in a better position to understand. So thank you so much.
I'm the CEO for a company called Cabot Solutions in InfoPark. I think in my company bio or something like that, somewhere it says AI in healthcare. So they looked for that and then said that we need to find somebody who has AI in LinkedIn to introduce Pradeep. So I think that's how I'm here. So I would like to say that I'm fortunate to know Pradeep, but I actually don't know Pradeep yet. I'm hoping to meet him and interact with him today. So you have to bear with me when I read his bio of the thing. So Pradeep is here representing ThinkBio.Ai, the company that he's the founder and president of. So he's been experienced of over 34 years of leadership across multiple industries, including healthcare, genomics, precision medicine, synthetic biology. The last two things I understand, SaaS and fintech. The company is focused on harnessing AI and synthetic biology to drive innovations in the biotech. And of course, anything that people put on AI will definitely draw a crowd to see what's happening. We are all eager to get the nectar from this talk here, I guess. He's also co-founder and CEO of Astonia Bio, which is also again involved in synthetic biology and high throughput antibody research. Along with him, we have Manoj Krishnan, who is the VP and Strategy for Innovation, VP Strategy and Innovation, for ThinkBio, and Shyam Mohan, who is the AI team lead ThinkBio.Ai. So please join me in welcoming Pradeep and team for this session, and let's have a thank you.
Thank you, Jacob and Venkatesh, for the kind introduction. So, just a bit of background, expanding on what Venkatesh gave the introduction to. So, myself, Pradeep Palasi, currently focusing on ThinkBio.Ai, which is a AI-enabled platform and solutions company focusing on biopharma and clinical healthcare, the continuum between research all the way to the clinic. It's based in California, both in Southern California and Silicon Valley, in South San Francisco, in the middle of the biotechs. We have a base here in Cochin. We acquired a company in October in InfoPark as our backend. So most of the development happens here. And most of the science team is based in the US and the solutions team. So we are a company which has three main components, which is science, which involves cancer biology, computational biology, cheminformatics, bioinformatics, synthetic biology. So we have a strong science team, then we have an AI team, and then the classic software team. So, like ideally, sessions about AI knowledge should be given by much younger people, but I have that advantage of having seen all of it for the last 34 years, to be exact. Involved in a number of successful companies and exits, primarily out of California, but started here as a social team of CalSoft, which was one of the early services companies which went public in the early 90s. So, so that's what ThinkBio.Ai is. So we're building a number of solutions. We'll see some examples of some of it today in the context of AI. So I know it's a mixed crowd, so some of you are already doing work in AI, some of it might be boring, but to set the context, I'll talk a little bit about AI, what AI is, what AI agents are, what different types of AI is, and then look at some of the impacts of that into the business world. So that's what we'll try to cover. So this is a general definition. There are many definitions, but essentially, these are systems that can, computer systems that can perform tasks that typically require human intelligence. So that's what AI is defined as. Learn, reason, problem solve, perceive, communicate. Those are the five main characteristics of an AI system. So we all interact with AI daily on multiple fronts. So, but just to look back at what it means. An AI agent is an autonomous system or a program. It can be an autonomous car, or it can be a software program. It can be a chatbot, whatever it is. But that perceives environment, learns, makes decisions, all of it, and to achieve specific goals. So it again defines what perceiving the environment, reasoning and decision making is critical for an agent. The next slide I will explain the difference between an automation and an AI agent. So learning and adapting. So that's a key feature of AI, right? Automation has been there for many years in software. I mean, a couple of decades at least, in different forms. So most of what you see on a daily basis is automation in software, not an AI agent. So the main difference and good analogy is between a train and a car, right? I mean, a train can do a good job of going through the track, carrying a lot of things, including people, but it cannot deviate, cannot change the direction. If it encounters anything on the track, nothing it can do. But a car, is more adaptable. So that's kind of a good analogy. And then the example is a little small, the phone, but essentially, if you set up an email system based on rules, the classic thing, customer emails come in, you handle it based on certain rules, you let it do certain things, respond to it, put into a spam folder, put into a certain flow, create tickets. That's a classic automation, right? But an AI agent doesn't run that way, right? It looks at a lot of data, it learns, it creates models, based on that it responds, it communicates with the customer, if the customer support system like that. So that's kind of a major difference between a automation and an AI agent. So it won't be none of this will be complete without talking about the AGI, artificial general intelligence. I mean, that's the next level of. So essentially, there are like the weak AI, the strong AI, and the super AI. right? And essentially, AGI is when AI is at the level of human intelligence. That's the high level definition of AGI. General purpose learning, common sense reasoning, and consciousness and self-awareness, which is a very complex concept, but essentially that's what AGI means. It is somewhat, or at least on par with human intelligence, at least in many general aspects. So that's what AGI is. And AGI is there, almost there. I mean, we are seeing AGI, forms of AGI. As you know, OpenAI recently announced O3, their latest model, which is they claim to be. In the next slides I'll cover it, but claims to have achieved AGI levels. So a couple of other more definitions. I mean, highly autonomous system, that's OpenAI's definition of it, highly autonomous systems that outperform humans in most economically valuable work. And another one, Microsoft and the generic economic definition. So this is the framework they use to evaluate the ARC AGI framework, which is the abstraction and reasoning corpus for artificial general intelligence. This is the criteria that they use to define, essentially test. It's IQ testing for AI, right? That's what ARC AGI framework is. So it solves visual puzzles, generalized, and then it should have core knowledge priors on subjects, and then it can work with limited information. So that's kind of the test that they do, right? So O3 recently beat the standard. It achieved 87.5. 85 is considered the human level of intelligence, but with some caveats, right? It did it with about 172 times the computing power. It's above the permitted level that they had originally in the test, but it was still able to beat it. So as you know, computing, is a linear function at this point. I mean, you can probably improve the models and all that to reach the level that they had originally ARC framework. So and more importantly, it was able to achieve 75% with original computing levels. So when they say AGI, and then that's the two, high compute and limited. They haven't released all the information on how the test was done, but at least so this O3 is going to be released sometime in January to public in a limited fashion. So AGI is here. So that is real. And then ASI is the next level that you see in movies, and it's artificial super intelligence, and essentially it beats humans. It can be highly unpredictable, at least in conceptually. It's only conceptual till now, right? So super intelligence, rapid improvement on its own, and then it can be unpredictable. So it's purely hypothetical at this point. You see in movies, people are worried about it, speculated. A lot of the worry about AI is based on the systems that will beat humans and will take a life on their own and reach the ASI level, but nothing is visible or practical at this point, but it could. So how are they getting to, the scaling laws, model scaling laws essentially is based on the number of parameters you use to train models, the amount of data, and the compute, those three things. So they have some rules about the scaling laws. So multiply that and improve that, and that's how you reach one level. And then post-training inference is where it can work with a limited set of, actually it can work with new set of information that it has not seen before. That is the post-training inference. And then, and then obviously a lot of basic research is going on, fundamental AI research is going on, trying to improve the whole, the LLMs all came from the, one Google paper, right, in the transformer. But there is similar research going on to improve this. So essentially, that's a path to AGI. And so the recent prediction is that minimum viable is 2 to 5 years, and general publicly available AGI in 2 to 10 years. but that could be faster. A lot of companies working on it, as you can see, the who is who in technology, with OpenAI and Google and Anthropic and Microsoft, everybody's at Amazon, Meta, IBM, and a number of Chinese competitors also in play. So, so this is the classic, this is the agency gap, as I say, right? On the left side, you can see the one in blue. This is like the determining chatbots that you experience usually in customer support now. It can go through only one path, right? It's a low agency. As against LLM based ones, you can see a lot more smartness now. And on the right hand is when you have a AGI based high agency, independent decision making level of AI. So the other thing is that simple agents that you already see a lot of them, and you can see autonomous agents, which is the new one, and then the autonomous multi-agents. Essentially, you're spawning a lot of agents to do different type of smart tasks, and then you're putting it together, right? That's a autonomous multi-agent. So that's conventional ones were like chatbots, which were text-based, voice assistants, virtual avatars, all those, and then it's going on to the multi-function autonomous multi-agents. So what are the benefits of using AI agents? Obviously, it's automation. Automation, we already saw automation and examples of it. And automation can be done better with AI agents. Efficiency, obviously, a lot of tasks that can take a lot of time for humans can be done by agents. Personalization, obviously, based on data, based on AI, more personalized and scalable, right? You can scale based on compute and your models and all that. You can scale a huge number of agents to do a lot of things simultaneously or better. So that's the benefits at a higher level. So again, a visual representation of it. Autonomy, they're goal-oriented, they're spawned to do certain tasks, very focused, goal-oriented, learning, they learn on the job, and they can interact with humans. We already see that in a lot of applications. So just some examples, some of them have been there for some time in the autonomous cars, the automatic trading agents on finance side, some healthcare thing, even Netflix personalization uses agents now. And then some more. So again, the key value, repeating it, increase efficiency through automation, increase productivity to handle multiple tasks at the same time, enhance user experience, personalized user experience, and innovation in new areas. For example, one of the areas that we are in, or maybe we are in direct research, target identification, things like that. In research, in science research, agents have a big role to play. So here again, some more example by domains in research, literature research, which used to take a lot of time to read the papers, identify. You have to typically go through thousands of papers in a latest subject to find the information that you're looking for, or the most relevant information. Those kind of things are now easily done by agents. Hypothesis generation instead of so it's self-explanatory. You can generate a lot of hypotheses and then test them automatically using agents. To give a good example, and some of the drawbacks that you usually hear about LLMs, which is hallucination, right? You already hear about hallucination. Hallucination is used as a proactive tool in research now, to generate new ideas, new sequences, for example, things like that. So, summarization of content is a very obvious example, and so human going through and reading and data set curation, again, is a huge thing. When you get large set of data, you need otherwise a lot of curators, human intervention, and a smart agent. Can do it much easier. and chatting to your own data. So a lot of those tools. A good example is something which we use called the AI bioinformatician, which is typically to look at large set of genomics data. You use bioinformatics tools, but you have to do certain set of standard tools to do it. But now, bioinformatician, a scientist can now have to traditionally had to go to a bioinformatician to get that results, but now they can query, even plain text query, they can query the data. So those are some good examples. In healthcare, it's a huge area of development, and there are some still high bars to cross in terms of patient care, right? And a lot of standards you have to meet to provide care directly to patients, but still the agents and AI is playing a big role in diagnosis, personalized healthcare, drug discovery. We'll see some examples. Precision medicine, as you know, precision medicine, personalized medicine are the two new frontiers of care, right? And precision medicine is when you are tuning care based on very specific parameters, and personalized care is when it's actually personalized by patient. So, and disease management, which is a huge thing for chronic diseases, whether it is long-term diseases. So essentially, agents can help patients and the clinicians proactively manage chronic conditions. Then finance, obvious. I mean, a lot of systems are all rule-based systems that traditionally be there on thing, but agents can make a huge difference in a lot of those areas. And already doing. As you can see, the investment scenario. I mean, this is a little understated probably, but the agent investment is growing. AI investment is growing. The AI agent market is projected to grow from current 5.1 billion to about 47 billion by 2030 global. And then, as you can see, a huge amount of investment going on the AI space. Just in Q3 2004, it's estimated about 6.5 billion. So it's a major area of growth. Again, for businesses, direct results. I mean, obviously, cost reduction, very obvious. Manpower requirements for certain function, whether it's customer support, whether it is analyzing things. So cost reduction, increased revenues, you get enhanced customer satisfaction, obviously due to driving sales through agents and AI tools, customer loyalty improvement by providing better service. So improve decision making. Traditionally, you had to ask for reports, ask for dashboards. Essentially, a lot of that can be improved by proactively using AI agents and analyzing data and forecasting. And then innovative solutions, competitive advantage, exploration of new areas, scalability and efficiency, manage workflows. I mean, it's a good leveler for small to mid-size enterprises to compete against a large workforce of a large enterprise if they have the right tools in place. So this is the formula. I mean, essentially, artificial general intelligence plus the multi-agent framework is emulating the human worker in a lot of areas. So that's what it means. Advanced reasoning. I'm not going to drain the slide, but essentially you can expect very powerful AI agentic systems to handle a lot of the tasks that humans do, and improving. I mean, essentially, the early days before AI came to you could still set up automation, but it was primarily you have to think through, set up the rules, set up all that. So a lot of it can be handled by AI agents. So yeah, I mean, again, a little bit more on the same thing, but some of the things, the hybrid human and agentic. So essentially, agentic frameworks helping human workers can improve the productivity quite a bit. And then SMEs have an opportunity to be agile competitors using the right AI systems and very personalized and hyper-personalized customer experiences. Those are all predicted, and they predict SaaS solutions to be hugely transformed using AI agents and AI workflows. So AI frameworks, agentic frameworks, agentic frameworks, many of them are already there. These are probably the top 5. We use the first, the first 2, Microsoft Autogen and Fluent.ai. And these are all available agentic frameworks. And again, perception, reasoning, and then action and communication. Those are the 4 things. Essentially, you are, through sensors, through data, processing your data, you're perceiving, your reasoning, which is the knowledge representation, the knowledge layers, the models, and then the action, which is either talking back to a chatbot, whether it is driving a car, controlling a car, all of that. Those are the action, and then the communication obviously is a key component of it. So typically, you don't probably need all of it, but it's all about data. It's all about setting up the framework. So the things you need in a traditional fashion to develop an agentic framework is programming, obviously, and then machine learning, deep learning, data science. Those 3 together, which can probably be substituted by some of the LLMs and foundation models. But again, ultimately, it all boils down to your own knowledge layers, your own data, the fine tuning you do, the RAG, all kind of. So it's all about your data, your learning, all of that, and then software engineering, which is part of any software release. And obviously, the most important thing is the domain expertise and the problem solving and critical thinking. And then the general AI agents. I mean, a lot of things. I mean, the value general AI agents. The domain ones probably have more value, practical value at this point, because of the deeper domain knowledge and knowledge layers that is built, and then they're easier to develop if you have the right knowledge layers, and obviously it can give more predictable and better user experience. I will explain what that means. So this is the area that ThinkBio.Ai is in, right? Like as I mentioned, we are an AI-enabled platform for digital biology. Digital biology has many components, including biology, bioinformatics, synthetic biology, all of it. So these are the 6 key components. You can see the architecture in the next slide, but essentially we are focusing on everything but the second one, which is experiment automation. But we have frameworks for research scientists, bioinformatics, synthetic biology, medical scientists, disease prediction and drug discovery. I mean, this is I'm talking about ThinkBio.Ai with context for biopharma and clinical everything. So this is our framework as an example. I mean, essentially we have those 5 layers you can see on top: research, experiment management, drug discovery, synthetic biology, medical scientists. These are the AI frameworks on top, and AI agentic frameworks on top, and then the knowledge layers. Just some examples, like the ChatGPTs of the world for natural language processing, then specific multiple layers of specific foundation models specific to our domain, sequences, molecules, mass spectrometry, things like that, and then obviously the data layer at the bottom, clinical trials, enzymatic reaction DBs, literature, research papers, multiomics, which is obviously the whole spectrum of genomics, epigenetics, and all the way proteomics, metabolomics, all of it, and transcriptomics, all of it. So So that those layers, and then the disease databases, specific databases. So this is kind of our agentic framework. It's an example of how AI agents can be used, right? So the example that I'm going to show, hopefully the video plays with sound, but essentially one of the platforms that we have is called Thera Blueprint, which is a digital biology. It's a platform that identifies a specific combination of gene targets for monoclonal antibodies, essentially cancer drugs, multi-specific, bispecific, trispecific cancer drugs. So it looks at a lot of different types of data, and it has different knowledge layers that covers cancer biology, computational biology, bioinformatics, drug databases, clinical trials, covers the whole spectrum, and then it comes up with a rank order. It comes up with success reports on what should be the target and how to do it. So essentially, that's what the platform does. So we are using this platform. We just filed our first patent on the output side of this generated using this platform. So what I wanted to say was that this platform has been there. We have been developing it for the last year and a half, but recently we forwarded with AI agents. So
specific and multivariate, paving the way for first-in-class and best-in-class interventions in oncology. Theora Blueprint helps in creating more effective drugs with reduced side effects, developing sustainable platforms for synthetic biology, and effective decision support system for antibody drug discovery. To begin, log into the Theora Blueprint portal using your credentials. Theora Blueprint offers extensive resources for cancer research, including 20,000 genes, 409 antibody drugs, covering 42 base cancer types, detailed information of 5,17,000 plus clinical trials, and tumor and normal gene expression of 20,000 genes in 42 cancers. Using our advanced AI agentic framework, you can perform detailed gene pair analyses. Here's how. Click on the Gene Pair Agent tab. Select Add New Analysis. Enter a report name and the names of the genes you wish to analyze. Click Start Analysis to begin. The AI agentic framework takes over, conducting in-depth research by integrating data from multiple sources, including web searches and the Theora Blueprint database. In just a few seconds, it generates a detailed report on gene pairs, addressing key questions posed by analysts and researchers. Details include generic information about co-expression, clinical trial details on bispecific antibody drugs involving these genes, combination clinical trials using these genes, and phase 3 clinical trials involving bispecific antibodies and combination therapies for these gene pairs. Theora Blueprint leverages the vast knowledge embedded in the data using advanced AI or ML tools and innovative data integration methods. The results are delivered in a comprehensive, user-friendly format tailored to your needs.
What it did was, so a typical 100-page research report with rank order for an expert research analyst, a scientist, it should take about 4 weeks. Now we can do it in 5 minutes. That's what it means. So that's using AI and our platform, both. But the AI agentic framework on top of it. So the team today have Manoj and Shyam there, but also I had them online, but we could not connect. But essentially, our science team also part of it. You can see. That's the team that was presenting today. I was the one who was doing the talking. So that's in a nutshell what I had as a presentation for today, but now open for questions.
Hello, estamos al paso de you talked about a whole lot of high-end things towards the end. And in between you said, how can SMEs be more competitive using AI?
So there's a little bit of a curve now to keep climb, because that's one of the questions that was asked in the chat about research also. It's a little bit challenging at this point, but it's changing, right? But I think once we have better access, the tools are already there, but now the resources and the knowledge, and that curve is a little bit steep currently, but that's changing even with the help of AI. I think once that is taken care of, I think it's a good level, very good level now. Because one example I was giving is that, we curators to create, you should obviously know what you're looking for, but we would have taken like 30 curators to collect the initial set of data that we did. But once we did that initial work, then now we can do it using AI. We just have one curator who knows what to look for, what to get, driven by research scientists. So that's even a leveler for us. I mean, a large company would have put 100 people to do it, right? So that's a good example. Customer support is a good example to give the stellar customer experience. 24/7, you typically need, at the minimum you need to run a 24/7 support operation. You're probably looking at minimum 15 people support at minimum. It's a small scale, right? You can probably do it with a fraction of it. So those kind of levelers are there, and people are coming with products that can let you do it. So you don't have to develop it also, right? So I think that's kind of the examples of some of the things.
With Excel data, a whole lot of Excel data. How can you go about it without too much investment in the app and computing power?
One thing we are doing in the specific domains is we are creating data platforms that you can use to do it, because you need a layer, and then on top of that you can, at the very simple level, it's as simple as prompting using ChatGPT or at the level. But if you need to now fine tune, for example, in your business, if you have specific need, what we typically do is that we don't use LLMs, we use foundation models and then tune it using your specific data. But that requires some computing skills. But I think at the base level, you can use the common available tools. I mean, you can take Excel as an input and you can ask questions. There are also tools that let you upload documents and ask questions.
Can you suggest a few other than
yeah,
GPT?
Some document, you want to play with some documents, and then
we can develop some RAG.
Are there any ready-made ones available that you can use? Like a document?
Yeah, we can do with the OpenAI platform. Other than
Does Facebook have any?
Meta, I mean, they have the. What is the LLM? Llama is the lighter versions also that you can use. But again, to run your own thing, you need certain skills to do it, right? So I think the simplest way at a preliminary level will be to use something like, essentially, you're giving them the data, and you're running your own models, and you're not giving them the data. That's a difference. As long as you're doing it on an experimental basis, you can use one of the OpenAI kind of tools, or Google Gemini. Those are the two most viable options, right? Google Gemini.
To ask you, talking about document summarization and generating a lot of insights. Are you also able to generate hypotheses? Mine is a two-part question. Part number one is, are you able to generate hypotheses?
You can generate, yes.
In your system?
Yes.
Okay. Now, to bring it back a little bit to a more generic context, if you replace all of your, all of your genetic stuff and all of that with, let's say, business data. So there are a lot of these SaaS tools that that generate data for all businesses. My question is, hypothetically, if you train models on all of this data from various business systems, and let's say I'm going out on a limb here, but they also train them on a set of HBR articles on various business issues. Could I possibly replace McKinsey with my AI model?
Yes, yes, actually, I mean, we the US now, a small, very small, 1 or 2 people once. So using AI tools, for $2,000, I can get a very comprehensive market research report, which CB Insights will charge me $200,000. So that's a good example of that. So
my question was also about hypothesis. So, I hired McKinsey to come in and tell me where I'm losing money.
Right.
And they will do 3 months of research, read all of your books, we've done this, we've done that and that, and we think you're losing money here, here, and here.
Yeah.
And here are these trends. So my question is, today, I don't know if there are things that essentially out in the market do that, and I would like to make one, that's why I'm asking.
Sure.
Is if I can possibly, and I don't know if the technology is there, if I can possibly, do these data interpretation type AIs, and then sort of, pair them with all of the breadth of data available in terms of business and consulting, reports and so on. If this can lead to hypothesis about my business, that would be priceless in my opinion.
It is possible. I mean, I'll give a good example. This is slightly off our very focused subject, but one of the companies that they have a lot of other services. So one of the companies, the customers is a big payments company, right? So they were able to create, fine-tuned models by which they can. Typically the way it used to work is that there's a payments division, there's a whole business division, but the payment division, and then they're the one looking at what's the prices they should set, what are the efficiencies that's happening, what improvements are possible, all of that. Typically, when you say they ask for a report, it goes to their finance department, then it comes to the development team, the data team, and then they create certain dashboards, analytics, somebody manually look at it. Now, created a layer by which the senior management can directly query, with natural language queries, exactly the kind of question that you asked. What is my best approach for this month in terms of improving my, payments margins, and it can, give you an analysis by customer. These are the customers you should focus on. This is a trend. This is general trend in payments. Kind of example. This is a good example of how it can be trained. So. No. This one they built for them. They use a basic model, foundation model. So that's something which we also do in our thing. I mean, which is what a lot of businesses should and do. I mean, you have a lot of these foundation models are trained with specific type of data, right? I will give you a science example, right? So we have one product we are building with one of the customers where we are using ophthalmology models already trained with about 1 million images, and then we are giving it like small sets of fine-tuning data, about 1,000 images, labeled images, specific diseases, say diabetic retinopathy or AMD. Essentially, the objective is to be on the field, identify just by those images or the fundus images with a 98% accuracy determine whether somebody is a candidate that should be followed up in a hospital. So that is using existing trained models, but fine-tune it using a very specific small set of data, which is what probably you will do. Look at a couple of those models, and then you have certain specific reports that you can consume and the trends that you can let it know, something like that.
Do you have any recommended open source models that we could use, because it's we are so dependent on these large corporations, very limited of them. So any recommendations? primarily foundation models.
Are there any, what do you think? Llama 3 is probably the closest. So you can have your own version, and then there are like different configurations you can use based on the computing you have, right?
Actually, Llama 3 the latest one, Llama 3.3 is better than ChatGPT. So you can use that.
Yeah.
Then actually we should focus on our area. What kind of problem we want to solve. Then we need to select one model based on our.
So, for example, the medical field, and there are MedLlama versions. There is a Mistral has Mistral has different versions. Other options.
If you look at the audience here, which are never really specific or deep, rather more general, and trying to get some intelligent answers from the data we have, or so where it's foundational models are actually good enough. And like the question on the Excel, maybe
I think
Google Sheet, just load data into Google Sheet, it actually has it all.
Now, yeah,
it's a now you can start asking questions too.
Yes.
And similarly, my question is primarily around for community like us, where something we don't really need deep expertise.
Right.
Something we can take from open source, build something that's useful, without really going too deep into, or even without even refining.
That's Llama is a good candidate.
So practically, if somebody wants to develop a small model where you are, a specific domain you train, what are the steps? How do you go about it? You're totally new about it. How do you practically go about it?
It's about the model scaling, scaling laws, right? There are essentially three things: parameters, data, and compute, right? It's all about it. So nobody can really develop an LLM, and nobody. There are companies, but nobody is trying to at this point because of the resource and that amount of money required, right? So the most practical approach is to take existing foundation models and then RAG or fine tune and specific to your thing, which doesn't require too much compute, because you can do with small data sets.
What's RAG, if I may ask?
RAG is augmented generation. So essentially, it is teaching these models with your data or knowledge layers to be more specific to your needs.
So I wanted to ask you about ThinkBio's future plans in Kerala. I came across an article stating your ambitious investment plans and creating around 1,000 job opportunities across the next 3 years. So this is a personal question. Like, I'm a recent engineering graduate. Do you think the current talent pool available in Kerala is, ready for the next level of AI that is going to be coming into the state? Or what are the upskilling plans that you have to get the talent to that level?
So we are hiring at three levels. One is a science layer, like I was saying, wide range, but science layer. Then you have the AI, AML, and data layer, and then the classic software. 1 and 3 has been easy. We have a very good science team across here and US. Software, obviously, we have a good set team already. The most difficult has been practically getting the AI and ML skills here. What we are doing now, we are able to get higher end. So we are hiring higher end. We are hiring trainees, junior, and then bringing up. The middle layer is very difficult, very high expectations and very low skills, to be honest. Out of the world. So what we are focusing on is now, we are focusing on AI side, we are focusing on lateral hires. We are hiring a large number of PhDs from maths, chemistry, physics, and then we are hiring good maths graduates from good schools, and then putting them together with fresh engineers, and then putting them under a very high AI umbrella, high-end resources. So that's how we are building. Very difficult to find, whether it's Kerala, whether it's Bangalore, wherever it is. People claim a lot of things, but very unbaked half-baked talent, which is with very high expectations. So difficult to sustain.
So we saw the combination of AI and genetic biology, right? And one of the quotes you had was from Mustafa Sulaiman, and he kind of paints a very scary picture. And so, what do you foresee the regulations in terms of how the companies or how the forces are going to use both of these things, AI and genetic biology, right? A combination could be very good, especially in drug discovery and all those things you said, or could be very deadly when going the other way, right? So what kind of regulations are coming? Do you know of anything that's coming, or are governments working on that, or what is?
Europe is a little bit further down the road, right? US is still lot is on the companies themselves to do it. But there is this concept about responsible AI, which is not a news, but so there are products we also have one product in the works on responsible AI that covers healthcare and biopharma. Essentially, it's a guardrail product that sits on top of AI models and focusing on safety. So that's the concept that's coming up from within software itself. So, but at this point, it's mostly self-regulated. I don't think there is anything which.
And how do you think with the new Trump-Musk administration in the
They
next
won't.
5 years?
They are generally, for all the other issues, they are generally good for businesses. So they'll be very hands-off on businesses. So I don't expect too many regulations.
Hands-off in the sense that the government will not have any regulations.
Yes, this administration is very unlikely to introduce any additional serious regulations on businesses in US and friendly countries, but they are going heavy on China and some other. For example, the Biosecurity Act. So now China had a lot of lead the last few years on some of the areas I was talking about. Now US is clamping down heavily on it already for preventing research or transfer of things. So it's an opportunity for India.
China is also leading on AI, right?
China is also leading AI, but a lot of conscious effort.
Not many of us we know about it.
That's right. And then it's so it's something like using Chinese products. I mean, a lot of companies are hesitant to use. They are doing good work. Last 10-15 years, they have done a lot of great work in AI. But again, I don't know how practical, useful that will be to the world.
Questions. Now, for pharmaceutical companies, especially in MSME sector, you come out with new products, Me-Too products. The challenge is stabilizing the product, bioavailability, and its shelf life. Can AI be used for that?
Yes, not small molecules, large molecules, but it applies equally to small molecules also. So essentially, we look at the value chain. There are a lot of if you talk about biologicals, then you are talking about identifying targets, designing antibodies to hit those combination of targets, synthesizing it, producing them, purifying them, scaling them, in vitro, in vivo, and obviously in silico is a new thing. Then you're talking about mammalian models, different levels of mammalian models, before it even gets to a phase 1 ready stage, right? So there are a lot of things happening in that, including a lot of things that can go wrong. Obviously, ultimately just go right, but a lot of things can go wrong all the way from design to production, right? Even before trials. So biophysical properties are an example. We can now predict biophysical properties before, you don't have to produce an antibody to figure out that it is not water soluble. Another example, if you want to clunk. You can predict biophysical properties. Yield is a big thing, right? I mean, unless you can produce them in sufficient quantities, so that can be predicted. So everywhere along the chain, you have tools that can help you improve the odds. Ultimately, it still has to go through, go to the human body at different levels, and then has to be proved safe on first level, and then efficacious on the second level, then mass efficacious on on the third level. That's 3 phases of clinical trials, right? But even to get to there, it's a huge ramp. So that's a journey. But tools are coming up. For example, toxicity models. You can predict all the toxicity is going to be even before something is ever tested. But again, as you know, you're from later areas. Human body is very complex. You still don't know. So there are parallel things going on. For example, immune system is the most complex human organ that makes the response to anything so unpredictable, right? So now the model is coming up that can, to some level, predict certain things, but not everything. So it's still very much dependent on the final.
Another question, we at TiE have such programs like TiE Young Entrepreneurs, TiE University and all that. We are going to embark on another program called Earn While You Learn.
Sure.
To make good employees out of students from colleges. Do you have any suggestions on that?
I think that's an upcoming concept here, right? It was kind of unthinkable to do things like that once you study, but I think it's a great idea. What you need is more industry tie-ups. I mean, companies are interested in grooming the talent and having a pool that they and the industry in general can pick up from. So I'm pretty sure that. But I think the important thing is that we always are behind a couple of steps, right? In terms of timing and in terms of how we get there. I think you have to think 2 steps ahead and start building those programs, right? So.
Okay. Hello. It's not a question that I have. I want to validate a direction of thought that I have in terms of AI. So basically, I'm trying to draw an analogy of the AI ecosystem that's coming to what has happened in terms of the digital transformation and the coming of internet and everything. So if we look at AI in terms of like when the internet came, a lot of software also came in, and that transformed a lot of way we work with the words and the CRMs. A lot of new software came in to solve our problems. Now, is it right to say that with all the generative AI that is coming up, that now we have a capability to draw insight or grab a certain level of context out of something? On top of that, if with AI agents, is it right to say that it's kind of working along the direction of how software used to do, to form with like RAG and everything in the place? Is it right to say that AI agents is like how software was, where in terms of in terms of at least like setting the operations and work?
What is that still software was mostly rule based, like somebody was thinking through how a system should work and put in the rules as the framework for any software. The major difference now is that you have AI coming at different levels where the software itself is trying to do that reasoning and decisions, which is the major difference. So I think it can be more revolutionary than what the classic software built template. If you look at development itself, as you can see now, a lot of tools, none of them are fully there, but still, a lot of it can be in the near future. Most of the routine things can be automated, right? Nobody has to even now start build all the screens from scratch. I mean, a tool can do it. So a lot of things are going to change about software and how it is built.
So do you see AI on a mainstream level the way we use it eventually?
Yes, that was one of the things that I did this year. But there was an article from Satyan Nadella who's predicted that the SaaS is dead. He kind of clarified later that he didn't mean in that sense, but essentially it's changing significantly. So I think to answer your question, absolutely yes. I mean, a lot of the things that require manual decisions, manual interventions, rule-based things, all of them are going to be replaced by very powerful software systems.
In edtech industry. So last week I was watching a YouTube video about a Chinese programmer. So in the past he used to have a job of around 100 grand USD dollar work. and now he is like working as a delivery boy for something like a Swiggy or something in the Chinese. So my question is like about the impacts of jobs when these AI agents comes. So basically, how it is now going is like in the past, people used to think that like programming is actually a good short job stream. Now we all know that like to develop a program or a software, we just need maybe 20 to like 10% of the workforce that we used to have. And even now they are like developing softwares which can like produce softwares. So since I'm in the edtech industry, I'm curious to know like what we have to like teach the younger generation like to get some secure jobs in the future.
Yeah, and a lot of the routine things are going to be disrupted, right? At different levels. I mean, it may take time, but ultimately it is going to be. It's like any other major revolution that has happened. Yeah, a good example will be, in the previous companies, I was looking for software developers of that level of skills. I'm not doing that anymore. I do a few, but I'm looking for much higher level skills and knowledge. Less number, but much higher level. So I think that's kind of the trend. I mean, it doesn't have to be that extreme, but essentially, even if you have all the tools to develop something, you should tell the system at this point what you should develop, right? And then see what it comes out with, and being able to validate it and all that. So I think if you're thinking about, like not you, but thinking about making a living by writing 1,000 lines of code a day, I think that is that.
What my concern is like right now agent. So I think after maybe 10 years or something, there will be an AI agent for any sort of work that you do.
A lot of the work it will be.
So what will happen? We have like 8 billion people.
Good question, difficult question, but it's a little bit of a unpredictable scenario in that sense, but it is unavoidable. So we better learn to adapt to that and find higher level.
And one question that I always have like, from the beginning of its mid journey, that revolution that happened, is like these LLMs used to like steal a lot of data from the internet, and there are like lot of legal issues that is like happening. So will this become a huge issue in the future? Like, can governments like stop like putting too much regulations for these things?
So there are some regulations already, right? I mean, not at the and luckily most of the rules are developed by people who have the resources to also defend it. But that's regulations are possible. Europe is already a little bit downstream in that, but I think it is even if you look at what Microsoft did when they came up with Copilot in the last year, they were indemnifying users against those kind of claims, right? So that's because they did enough work in the backend to be confident about not using others' code and using only what is publicly usable and all that. So companies are doing things. The early generation, they tried to grab everything out there and try to learn. So
sort of, we're wading the waters of what is possible. I thought I'd throw my hat in and ask a question, generally economics. So if you think about AI as something that leapfrogs efficiencies, that's what it comes down to, right? What might take 8 billion people to do, you can make one super intelligent system to do, or one or few. Now, the profit that a business makes is usually a factor of, I put in so much it costs so much, and then I have some intellectual property, or I have some efficient way of working, so I charge a premium on it to the extent that I can, because I hold the intellectual right or whatever. I bring some amount of unique value to the product. AI to me has a couple of knots there. One, that it is no longer intellectual, right? I've taken from the general intelligence of the world. So today's laws are not going to, protect me very, very fiercely when it comes to me taking the profit. Second thing is that now I've become super efficient. So me and everyone else, because everyone else is using AI also. So being super efficient means that I can make more with little. So again, long-winded thing. Two sides to it. One is intellectual property, and the other side is super efficiency. Are we expecting inflation to be negative? Because now prices might go down, then go up, or is that even possible? Wishful thinking.
I don't know. Anytime productivity has increased, generally the whole economy has improved, right? It's a historical trend, but this time it's slightly different, like you said. I mean, there are other implications on the intellectual property side. Even now, you cannot claim a lot of type of intellectual property already, right? I mean, you cannot, for example, if you discover a new gene by any chance, you cannot patent it, right? Because it's part of the human system or biological system, right? So there are a lot of things that you already cannot protect. It is already, but if you do specific methods, generate specific methods, tough bar, but if you have specific output, very specific output, you can probably protect it as intellectual property. So those variations even now apply. So I don't think
my point though is, if it has come to a foundational model that so many people have contributed on, it's not my unique competitive advantage. It's not mine to.
No, that one is not yours. Yeah, that is unique, maybe yours. That's what how the intellectual property laws work, right? So essentially, it is no different in many senses. As well as you can find something in Google, read about it, because it's public. Somebody's put it out public. You can use that knowledge. You cannot use their specific IP, but you can use that if somebody has chosen to publish it. You can use that knowledge because you learned it. You cannot claim that knowledge, but you might create a new product with that knowledge, which is unique. You can claim intellectual property on it. That's it. I think it's not any different than what we do now, but it's a little bit more complex because at this point, the problem with and the advantage and the problem with LLMs is that nobody knows what it learned, right? Nobody knows what it is learned because it finds knowledge and finds patterns that is beyond human comprehension. So it's very difficult to explain some of how you got there. So it's a challenge.
I was not looking for that already.
That's right.
Now, the reason that I was asking, and I'm sorry for that rabbit hole when I was thinking as I was talking, but the idea is that for any business person planning for the next 20 years, in any business, not technology, should we expect foundational things to change? And I'm not, right? The democratization of a lot of this information, the same tools being available to 100 people, the productivity increases across the board. So what we have been thinking about, money being made by large corporations sort of sitting on large piles of unique advantages, they are going to erode, I'm assuming. And if they erode, the way we plan for our businesses to grow in the next 20, 30 years, I don't see a lot of discussion about it, generically. But I think it should fundamentally change.
I think a little bit unpredictable also what form it's going to take, right, to be honest. But if you look at, if you like us selling, the O3 model, if you had to use their, compared to whatever else they were doing, they're charging, the minimum is $2,000 per subscription. And then token, all the other things that comes with it. So somebody is making money, big corporations still, right? And because they know not many people can build API. And that'll be a challenge, but I think that's like anything else at this point. So.
In line with that thought, right? So since you've been developing AI for quite some time, right? So we had a different way of developing different models, mathematical models, AI out of it, etc., which changed a lot 2 years back when LLMs came out and LLMs started becoming very popular, right? So I'm just curious to understand how your AI development process has changed since LLMs came, and how are you expecting if an AGI comes? Is there still scope for these small language models or small models to be developed still, at least in specific niche areas like healthcare?
There definitely is. There is discussion. Most of the user experience, most of what people see is about generative AI. As you know, generative AI is only one small aspect of AI, which is generating content, which was not possible before ChatGPT came along. But where specific applications, domain expert applications, will require much more than that. Like you said, smaller models with specific type of data, which the LLMs cannot, for a number of reasons, emulate without things. I think there is definitely, that's where most of the practical applications are going to be. The generic applications on the world will use the LLMs and the generative AI based thing, particularly when there is a lot of human interaction, conversations, all of that.
Coming into LLMs,
sure.
People talk about function calling, or basically taking multiple paths to the same problem and trying to find a solution. And in OpenAI's research and everything, it is said to be that is said to be the paths to AGI, or pseudo paths to AGI, however you want to call it, right? So, in that, do you see the current transformative systems or LLMs in general taking us to the world of AGI and actually replacing a lot of non-generative use cases as well? Right?
Methods are, even now becoming kind of irrelevant, right? I mean, because the way you had to do it and the effort involved and the data that you need to have and all that. So to that aspect, yes, this broader, more general systems will let you do things that you didn't have. You had to do with a lot of effort earlier. So absolutely.
Applications like healthcare will
still very, very, very relevant, right? Because I'm of one of the projects that we are doing, and now, so this was attempted, by Google, nobody less than Google, 3 years back, where they took a lot of images and tried to do a solution for one of our customers. They could get into it 82% accuracy. Using some of the foundation models and about 2,000 images, we can already get to 90% accuracy. So for specific applications like that, specific domains, what matters is the power of some of these models plus how you tune it.
For all of you who have assembled here, TiE Kerala, we thank our own Pradeep. Thank you very much, Pradeep. I think you made yesterday's and today's session very interesting. We thank Manoj Krishnan and Shyam Mohan, both of you. Thank you very much. The participants, thank you very much for turning up. Without you, this would have been not worth it. And we thank our secretariat who have done a good job. We need your feedback. Please do let us know how TiE can improve on such sessions and what are the sessions you would like. Do give us your feedback. We're going to have a group photo immediately, then we can have a cup of tea after that. Please do join out here. Thank you.